to Statistically Speaking. Statistically Speaking.
Today, the challenge is using visual aids. So I picked a subject that shouldn't detract from the actual visual aid, statistics, because you all go to sleep in about 8 minutes. But, and to try to tie it in, I looked for a quote to tie it in. The closest I could come was from Lisa Minnelli. Smoking is one of the leading causes of statistics. I have another quote for you that is attributed to 2 different people, Benjamin Disraeli and Mark Twain. There are 3 types of lies. Lies, damn lies, and statistics. With that in mind, I'm going to take that subject that even math majors fear, statistics, and try to communicate a little bit about it. With that in mind, I brought this device. One problem with statisticians is we have our own priesthood, and we have our own religious jargon that the rest of the world is not allowed to understand. We use words, it's not bad enough to have average, we have to have 3 more terms for it: mean, mode, and median. We have standard deviations, we have squared mean squared error, and this device, which is essentially a random number generator used to teach statistics, has a formal name. And if you can use it in a sentence, our lexicologists will give you credit for it. This speech is broken up into 5 parts, really. The rule of big numbers, on average, shift happens, what's the spread, and you are what you assume. With that in mind, I need a volunteer for today. Who wants to volunteer, Chuck? Chuck, I have a very simple task for you. Come on up here. This is a complex piece of technical equipment. So
yes,
you have to
I understand that.
Now, your job is to take this slide and slide it across. And if it sticks, just kind of work it back and forth. How did I get a nail in there? Just work it back and forth. Okay? Well, that's all right. Just work it back and forth and run about half of them down.
Oh.
Okay, the way this works is the beads come down and hit pins. The pins, there's a 50-50 chance of going one way or the other. They're staggered, so the probability keeps building as you go out there. And it's very small you get to the outside, much more that you're going to land towards the center. This falls into the rule of big numbers. Stop for a second. We have a very small set of numbers down here, and if you can see it, it says most of them are falling right around here. The rest are spread to either side. That big list, now go ahead and finish running the first half. That big number is going to be the average, and we're going to see variation around that number. All of statistics is based on variation. Aaron Levison says, statistics are like bikinis. What they reveal is suggestive, but what they conceal is vital. Which starts us on this subject of average. Average means what's the center? What's the target? What's the middle value? We have a lot of different terms for it. Statisticians are a little strange because they would say if you're standing with 1 foot in the oven and 1 foot in the ice bucket, on average, you're perfectly comfortable. That's from Bobby Brackett. The idea behind average is it establishes what your target is, and it's also, we have our own term for it. We call it central tendency, but it basically means it's the middle. It determines the accuracy of how close you're coming to some target value. Then we get to shift happens. Shift happens is a popular statistical term that gets somewhat modified in the public market. But what shift happens is, if you can stop for a second, if you look at this, everything's accumulating over here to the right of center. That's because this one is offset. It's off target. Nothing always stays on target, and sometimes statisticians will collect that data, take it back and say, hey, the center's not where it's ought to be, it needs to be shifted. And we can get rid of those. Now go ahead and run a few more out there. And while he's doing this, what shift means is the movement of that center average. This is very easy to do with some processes because all you've got to do is move where you set the machine up, where you set the process up. It's a little different because politicians are always trying to shift the average, and that's a much more complex process. As he does this, there's a second term that comes in, and that's the spread. The spread is how well these are distributed. If you can look, you can see we've shifted this one, and the center is now in the middle. The spread is how wide those are. If you look at the bottom group here, we've spread quite a bit across that. Go ahead, you can crank out some more. That spread is called the variation. And they'll use this wonderful term, standard deviation. And you can stop for a minute. We use the term standard deviation, and standard deviation is a measure of that spread. And what they said is we need to have some way to tell these apart. So the way they did it was they started squaring the distance as you went out. What that means is the ones further away count much more than the ones that are in close. The one that is twice as far away counts 4 times more. So they develop a measure of spread, and that's what standard deviation is. You can improve on that spread, and you can reduce that spread by changing the variation. One way to change the variation is take some of it out. And that's what this thing does. So go ahead and crank out the rest of those. You get these things called outliers in there, and the wonderful thing about outliers is statistics say you can throw them out. The problem with that is because they are weighted much more heavily than the ones that are close, you throw it out, maybe you lose something. So when you throw those out, this is what happens with your climate models. They throw out the outliers so that they get the kind of answers that they want. Problem is, then the predictions don't come out where they want, which leads you to George Box, the famous mathematician, who said, all models are wrong. But some are useful, but all models are wrong. This is one of the problems with some of the climate models. This is some of the problems with some of the information communicated in surveys. Okay, you can stop here, Chuck. Thank you very much. You were great. I don't know if you've noticed, but before where we went to the yellow and red, now we're grouped in here around the yellow. This gets us to you are what you assume. When we look at statistics in modern life, we go back to the climate folks, and they assume global warming's happened, and they build models to verify that. Then they get surprised when we don't perform according to the models. And that's because they started with the assumption of where they wanted to end up. Statistics comes back to how do you use the numbers, and how do you use the numbers to reflect reality. There's a lot of ways to do it, but I'm reminded again by a quote that is attributed by the famous German Goebbels to Winston Churchill. Do not trust any statistics that you do not fake yourself. Thank you very much.